All right, we're going to talk about solving systems of equations algebraically. All right, so we have two methods to solving algebraically. We have substitution, we have elimination. In substituting, what I'm going to do is I'm going to solve for one of the variables and substitute what that variable is equal to into the other equation. In elimination, what I'm going to do is eliminate one of the variables. So they have to be opposites of each other, so when I add them together, they get to 0. So here's my first set of equations here. So it says 3x plus 4y equals 12, 2x plus y equals 10. So I'm going to use substitution here. So what I want to do is I want to see if there's an equation that I can solve for one of those variables very quickly. Well, it's the second one. It's this orange equation. So I'm going to subtract off 2x. So I have y equals negative 2x plus 10. I'm now going to take that and substitute in for my other equation for y. So I end up with 3x plus 4. I'm going to go ahead and use my orange marker here to just kind of show you where it goes. Plus 10 equals 12. Okay? So now I'm going to solve these out. So I'm going to distribute my 4. So 3x minus 8x plus 40 equals 12. I'm going to combine my x's here, so I have negative 5x plus 40 equals 12. I'm going to subtract my 40 over negative 5x equals negative 28. Divide by negative 5, I get x equals 5.6. Okay, so now I have x equals 5.6. I'm going to substitute that back into one of my equations and solve for my y. So I can actually use this one here, my simplified one. So I have y equals negative 2 times 5.6 plus 10. That gives me a negative 11.2 plus 10, or negative 1.2. Now, most of the time it wants you to write it in coordinate form. So I'm going to go 5.6 comma negative 1.2. And there's my coordinate of my point. So now I'm going to do the same thing here, but I already have one of my variables solved for. So I'm going to take this whole piece and plug it in for my x here. So I end up with negative 2 times negative 3y plus 5 minus 4y equals negative 5. I'm going to distribute my negative 2 through, so I have 6y minus 10 minus 4y equals negative 5. Combine my y's. It's going to give me 2y minus 10 equals negative 5. Add my 10 over. Okay, so 2y equals 5. I'm going to divide by 2. So I get y equals 5 halves, or 2.5. Okay? I'm now going to take that value and I'm going to plug it back in. So most of you probably prefer working with decimals. That's fine. So x equals negative 3 times 2.5 plus 5. Negative 3 times 2.5 is negative 7.5 plus 5, which gives me negative 2.5. Now I'm going to write this in coordinate form. So negative 2.5 comma 2.5. And there's my coordinate. Okay. Now, in elimination, if you see in our first equation here, our x's are already opposite each other. So I can just add straight up and down here, and these end up canceling out. So 4x plus negative 4x, they go away. 2y plus 3y is 5y equals 25. I now can find my y, which is 5. Okay, so there's my y. Now, to find my x, I'm going to take my y and plug it into one of those equations. So 4x plus 2 times 5 equals 9. 4x plus 10 equals 9. Subtract my 10 over. 4x equals negative 1, or x equals negative 1/4. There's my x. Now, if I want this in coordinate form, negative 1/4, comma 5. Now, in this one, I want you to notice that I don't have opposite values here yet. Okay? And if I don't, what I can do is I can multiply one equation by a constant number, and I can actually multiply each equation by a different constant to get it to be where they have the opposite coefficients. Okay? So it doesn't matter which one of these I work with first. So I'm actually going to eliminate my y's first just because I chose to. So I notice here that I have a -8. This is a positive, so I already have opposite signs. So I just need to get this 4 to become an 8. Well, to do that, I'm going to multiply by 2. So I'm going to multiply the top equation by 2 to get it to be that form. So there's my multiplication out. I'm just going to rewrite this down here. -2x plus 8y equals -8. I'm going to rewrite my second equation here. Okay, so -2x plus 5x is 3x equals 12. I'm going to divide by 3, x equals 4. Now that I have my x's, I'm going to take my x and I'm going to plug it back in. So I'm going to plug it back in up here. So I have -4 plus 4y equals -4. Add my 4 to both sides. 4y equals 0. 4y equals 0. So my coordinate then is 4, 0. Now, these are all consistent, independent solutions, right? We found one xy coordinate or one solution to each of these. Now we're going to talk about how do I determine if it's inconsistent or consistent dependent. So we're going to kind of look at these equations right here. So I have -3x plus y equals -5. 3x minus y equals 5. I notice that they're opposite each other, so I'm just going to add up and down. So that's 0 equals 0. Well, when is 0 equal to 0? Well, it's always equal to 0. So this is going to be infinite solutions, okay? Or we are consistent dependent. Okay? So there's infinitely many solutions. All right. Now let's look at our next one. So we have 4x minus 4x, that's 0. -6y plus 6y is 0 equals 16. Well, when is 0 equal to 16? Never. So we have no solution, which says we are inconsistent. Right? Showing that these are parallel lines, showing that these are the same line. So that's solving systems algebraically.